Howdy! I just finished the first term of my PhD program at the Okinawa Institute of Science and Technology. Before the next term starts, I want to make some videos explaining what I've learned. Last week, I gave a slideshow presentation at 9 p.m. for the audience in Japan, 4 a.m. for me in Los Angeles. I managed to stay awake because the project had me so motivated. You should remember my videos about catastrophic forgetting. We will probably always remember what the digits 0 through 9 look like. A convolutional neural network can learn to classify digits pretty well, but if you only train the network on 2 digits at a time, well, it'll learn to tell the difference between 0 and 1, then forget that when it learns to tell the difference between 2 and 3. Then forget that when it learns to tell the difference between 4 and 5, and so on. We can prevent this forgetting using FROMP, Functional Regularization on Memorable Past. When we train a neural network to do a new task, we can tell it not to change its answers to memorable examples from previous tasks. Now the network can classify all the digits 0 through 9 even though it trained on just 2 digits at a time. So my project for this term was using FROMP on reinforcement learning, the kind of machine learning I used to make the computer play Pong. Personally, I remember how to play video games I haven't touched in years, even though I've learned to play different video games along the way. Can a neural network do that too? Here's the plan. There's a Python package called Minotaur, which provides miniature Atari games. Minotaur, Pong seems simple enough for you and me, but it's pretty big for a computer, 210 by 160 pixels, each with 3 channels of integers from 0 to 255 for red, green, and blue. In comparison, here's how Minotaur presents Breakout. It's only 10 by 10 in width and height, and it has 4 channels which are Boolean, true or false, 1 or 0. Where's the player? Right here. Where's the ball? Right here. Where was the ball in the last step? Right here. And here are all the bricks you've got to break. Each game in Minotaur has 6 controls: none, left, up, right, down, and fire. In Breakout, all you can do is move left and right, or do nothing. Space Invaders is a lot like Breakout, except you can fire too. You've played Space Invaders. Asterix is completely different. I've never played Asterix before. You can move in all 4 directions to avoid enemies and collect gold. I had my computer play each of these 3 games randomly 1,000 times, and averaged the scores. If you play randomly, you don't do very well, do you? But Minotaur's GitHub repository offers a deep Q network, a reinforcement learning algorithm which can learn to play. Let's try it out. I trained the Q network on Asterix for an hour. Look at that. The model plays Asterix pretty well, but it still doesn't know how to play Breakout or Space Invaders. So let's train that same Q network on Breakout for an hour too. Now it can play Breakout pretty well, but not Space Invaders. And it's forgotten how to play Asterix. It plays Asterix just about as well as randomly. And after we train the Q network to play Space Invaders for an hour, it mostly forgets how to play Breakout too. The catastrophic forgetting. Just one step before I move on. These games score the player differently, so it's a little hard to compare these scores, huh? Here, I've normalized the scores by scaling them down so that the highest score in each game is 1. That's what these graphs look like for the rest of the video. To avoid forgetting by applying FROMP, we need to pick out the most memorable moments. We picked the most memorable MNIST digits using a Gaussian process, but I wasn't quite able to apply that to reinforcement learning, so I've got 2 approaches. First, I just picked out memories at random. This isn't FROMP, it's called FRORP. FRORP. I trained the Q network on Asterix for an hour, as per usual. When I put down Asterix and picked up Breakout, I also saved 3,000 random moments occurring in Asterix. While the model trained on Breakout, it was punished for changing its answers to those moments from Asterix. Next, while the model trained on Space Invaders, it was punished for changing its answers to moments from Asterix and Breakout. I played 1,000 games again in 7 ways. Playing randomly doesn't do well. Without Frorp, there's Catastrophic Forgetting. With Frorp, the model doesn't get quite as good at Breakout, but it does barely seem to remember how to play Asterix. And after learning Space Invaders, it still plays Breakout just fine. Okay, now let's redefine memorable so we can try Fromp. That Q network works by turning a game state into its expected rewards if it made each of the 6 possible moves. Here's what I'd get if I did this next. Here's what I'd get if I did this next. Let's say a state is memorable to the model if those 6 outputs have high variance. If the model expects exactly the same reward making any of the 6 moves, that doesn't sound so important to remember. But if the model expects a really high reward with one move, but a really low reward with another move, that sounds like a strong opinion which should stick around. I went through all the training again, but instead of picking 3,000 states at random, I picked the states with the highest variance in the model's output. How did that work? Not bad. It's good at remembering Asterix even after learning Breakout and Space Invaders. Here's Frorp's results next to Fromp's results. Pause if you want to compare them. But now this is the cool part, I think. Let's compare one memorable and one forgettable state from Asterix. Which do you think is which? In this state, the player's over here, there's an enemy way over here, and there's gold down here. In this state, the player's next to 2 enemies, and there's gold way down here. Obviously, this is the memorable one. The player's gotta move, or else the enemies hit him, and the game ends. Here are some more states from Asterix. Here are some from Breakout, and here are some from Space Invaders. I'm moving quick here because I could spend hours talking about these, and this video is already long enough. I learned a lot doing all this. I was proud of showing this stuff to my lab mates, proud enough to stay up until 5 a.m. answering questions until I passed out. If you have any questions, hit the comment section, and check the links in the description. My next Squid video will be about RTD3, which I presented to my class at a much more reasonable hour of the day. Bye-bye. By the way, I've got a Patreon at patreon.com/thinkster. I want to thank all these squidlings and elder squids. Thanks.